Good morning, all. Sorry for the delay by few minutes. We'll start. My sincere apology. We are taking the class on today due to the paucity of time. There is no choice for me and also for you. Kindly bear with me. As we discussed yesterday about the thermodynamic laws and other things, let us move on to a topic on aerosols, particularly a very interesting and important feature in the field of atmospheric physics. I hope you are able to hear my voice and also able to see the slide. At least I need one yes.
Yes, sir.
Okay, fine. We'll continue. I'll go very slowly. Okay, don't worry. This is the third and fourth. It is a broad classification. What we divided the syllabus in the first unit actually. Aerosols and its properties. Then maybe we'll move to the atmospheric dynamics. To the extent I will cover the third topic. Maybe then we'll take it up the fourth one in the next class. Maybe some missings and other things we'll cover after completing all the topics put together actually. Here, aerosols are nothing but heard of the word actually suspended particles in the atmosphere, like particularly the dust particles. We can call it as a dust, like a dust of any kind. Even if you're grooming your room, then you will get some kind of a dust, but it has to be suspended in the air actually. To suspend in the air, it must have a relatively lesser mass, or the density of the particle should be in such a way that it has to float. Should be the density put together should be slightly less than that of the density of the air. Otherwise, it is can't actually. Means, but if you under the pressure, if you put all the dust particles put together, certainly it will be a more dense, and it is also having a higher mass of that kind relatively. Aerosols are nothing but suspended particulate matter in the air. SPM, they will call suspended particulate matter. Aero means air, atmospheric air. Sols means whichever is suspended in the air actually. If that is the case, if you suspend a balloon, if you suspend a bar magnet, for example, through a thread, that may not be the aerosol. Means what I want to say is that actually particles of the relatively lesser dimension, they have to suspend themselves in the air. For example, maybe a dry leaf of any of the tree, if it is floating, maybe flying in the air due to wind, we can't call that as the aerosol actually. Very fine particles. The nature of the material should be the particles. It should be the solid particles, or even liquid, but not be gases. Either solid or liquid particles they can call. They are known as the aerosols actually. But we should not have the water vapor. Water vapor is a gaseous in nature. Nitrogen is gas. Oxygen is gas. Argon is gas. We have to exclude. No molecules actually. No molecules. No atoms of that kind. But it should be particle in nature. How that has to happen, we'll see that. Then we have to see that how their concentration or maybe the number will vary. Concentration means whenever you are making the measurement of the concentration of any of the sample in our chemistry lab, maybe physics lab also we can do, there is no discrimination between physics, chemistry, mathematics, or computer science, or geology, geography, as you go deeper into the subject. In the sense, as you are going for higher learning, maybe in high school, the syllabus was in such a way that curriculum was in such a way that for you, a broad view of science, broad view of physical science, broad view of chemical science, broad view of biological science. You might have text to text. One is for physical science, it combines the physics and chemistry for you, and another one mathematics, other one is the biological science, maybe combining botany and zoology together. But as you come for the +1, +2 of +2, physics is different, chemistry is different, mathematics is different, botany is different, zoology is different. You go for the graduation, okay, in the physics, optics is different, mechanics is different, then in the sense different papers, or maybe you are going well deeper actually. Okay, then maybe the what can call classical mechanics is different, mathematical physics is different, atomic physics is different, modern physics is different. As you come for the still higher studies like master degree, like statistical mechanics, classical mechanics, mathematical physics, electrodynamics, all papers put together maybe are different versions actually. Means you are learning deeper, where the each and individual topics may not be topic, each and individual disciplines acts like a highly specialized subjects for you to learn. Okay, in the first and second semester you learn them. Of course, you are inside the first actually you are learning them as an independent. But if you join for the third semester, maybe second year, Okay, you will go with the different elective or the specialization. Maybe specialization in nuclear physics, specialization in particle physics, specialization in condensed matter, specialization in atmospheric physics, specialization in the spectroscopy, specialization in space physics, specialization in planetary physics, specialization in what we can call astrophysics. So much of things actually. If you are going for the fourth semester, need not be the semester wise, still higher actually. You can take up further deeper. If you join for PhD program, you may be doing only a work on how the time changes on the earth, how that atmospheric air moves, what must be the kind of a wind. For example, if my case is considered, okay, how aerosols are changing their contribution, how aerosols are influencing the atmosphere, or how atmosphere influences the number of the aerosols. Otherwise, how these physical processes are impacting the mankind, or how the mankind impacts these physical processes which are occurring around them. That will be in hot issues. How the change in temperature occurs, or how why the temperature has to change. Why the temperature has to change? Is that change in temperature what we are seeing is it associated with the change in the temperature locally, or is it the change in the temperature due to the global? Is it the weather what we are getting right now from last 2 days because of the cyclone? Is it due to the change in the phenomena only over ocean? Or is it changing the temperature over land also? Is it because of the corona also? Is it because of the earthquakes? Is it because of the lightning activity? Is it because of the natural calamity? Or is it because of the man-made activities? Is it because of the stoppage of all mankind activity might be leading to some kind of an activity by the nature to balance itself? Or even the climate change, they can call. Climate is nothing but the average of the weather phenomena for about more than 30 years. Okay, maybe the increasing in temperature, we don't know. Decreasing in temperature, we don't know. Okay, maybe increasing in pressure, maybe increasing in water vapor content, maybe increasing in comfortability. That one has to see that. All these things depends on our understanding. Atmospheric physics lies with the aerosol particles. They are very highly special kind of particles which exist in the atmosphere. What we are able to see that, and their total concentration they can call actually. Okay, sorry. I was about to tell about the concentration. Means in chemistry you studied that the amount of the molar mass of some compound, for example, whether the sulfuric acid is highly concentrated or not, or maybe diluted. Maybe milk is diluted or concentrated. Concentrated means it is full of only milk or it is mixed with water content. Okay, maybe gold. Is it 100% pure in terms of not be the concentration, maybe the number density, or is it having some impurity? Okay, maybe like even diamond you can take. Okay, if you take some kind of a fruit, whether that is maybe some milkshake of that kind actually, whether it is made up of the same milkshake or it may be contaminated with something else. Contaminated means is mixed with the water for dilution. Then the size spectra, how that size of those molecules will change actually. Then sources and things, of course, a broad spectrum. You will restrict our study only to few points actually. Then effect on atmospheric phenomena. In general, we will discuss from all the three together, put together. Atmospheric dynamics will take later. It is not an issue. We will go ahead with the rest of the part. Okay. Atmospheric aerosols, only see this statement, are suspensions of small, solid, and or liquid particles, excluding the cloud particles. Okay. Why you have to say that? Because cloud particles are of different nature, preferably of water vapor in air that have negligible terminal false peak. The range of particle size that play a role in the atmosphere ranges from few nanometer to few, sorry, here one few is missing, few nanometer to about few millimeter. Few nanometer is of the order of 10 to the power of minus 9 of a meter to the order of about 10 to the power of minus 3 of a meter. It varies by an order of magnitude by 6 to 7 orders. Maybe you can take 6 orders, it is not a bad idea. Here, two things you remember: suspension of small particles without having any tool. Okay, solid and or liquid. Use this special terminology and slash r, solid and liquid, solid or liquid, but should not be, you don't call it as either solid or liquid. If I use, it should be either of the one. Solid and liquid, if you use both together, then it should be in the combination of solid and liquid, neither solid nor solid liquid of that kind. This terminology, preferably in science, they will use in such a way, it is combining with either solid alone or liquid alone, or combination of the solid and liquid put together too. Okay, excluding the cloud particles, that will come later, where their terminal speed should be very less or negligible. Terminal speed is nothing but if you allow them to fall under the gravity, without the attraction they have to fall. Okay, without the, if you put g as 0, it has to fall immediately of that kind. Terminal speed is a speed which is attained by a particles, attained by a particles, where they have to move with very negligible. Negligible means in such a way, whether you can expect that whether it should be of what kind of a speed of that kind actually, what kind of a speed. The thing is that the maximum velocity may be unattainable by an object, which can say that as it falls through a fluid, particularly in the air, it occurs when the sum of the drag force mainly because of the friction, and the buoyancy force which is acting on those air molecules, that should be equal. Drag force is the drag due to the friction caused by the air, and the what we can call the buoyancy force is the force mainly because of the size of the particles, preferably to the downward force due to the gravity which is acting on the object. Since the net force on the object is 0, this because it is balancing, the object has a zero acceleration. If that is the case, then the particles said to be falling under the terminal speed. Terminal speed means gravitational force has to match with the buoyancy force. Gravitational force is a downward force, buoyancy force is an upward force. If they match, particles will float, or they will suspend. Here, see the chart they can call actually. It is in such a way. See at the bottom, size range of particles in the atmosphere and their importance. Starting from the distribution particle diameter, we are saying that size means preferably we are speaking in terms of the diameter, not in terms of the radius. Okay, about a 10 to the power of -4 micrometer, almost 1 angstrom, not almost, exactly 1 angstrom, to the order of 10 to the power of 3 of a micro, means about millimeter. Means starting from 1 angstrom till to the extent of the millimeter size. You might have surprised that the size of 1 angstrom, you are having well aware that the molecules exhibit that size. Molecule of an hydrogen is a few angstrom. Okay, molecule of a nitrogen is a few angstrom. Bohr radius is about 0.53, or maybe the diameter itself is about 1.06 angstrom, 1.06, 1 angstrom of roughly 1 angstrom of that kind. But thing is that they will not go with the extent of the molecular dimension. That is why here I am saying that it is in terms of the nanometers. Few nanometers, about 1 nanometer, 2 nanometer, 5 nanometers. Shall I call it as a few means 10 nanometers also in few nanometer? Fine, no problem. Okay, but can I call 0.1 nanometer? 0.1 nanometer is equal to 1 angstrom, remember. Okay, it should not change by an order. You may be varying from 1 nanometer to about 1, even about 0.5 nanometer to about almost about 9 nanometer of that kind. Okay, that is the lowest size. In the graph or chart, you see that there is no y-axis. It is only the classification. Y-axis is in such a way that how we are classifying the particles depending on the size, and it is also showing that where they are finding its applications actually. Where they are finding its applications. Starting from about few nanometer, you can call it as the small ions. Ions are nothing but, for example, hydrogen atom is there. If you remove an electron from hydrogen atom, it is an unfortunate. Okay, because hydrogen atom possesses only a single electron. If you are removing an electron, it becomes a nuclei. Okay, Okay, instead of hydrogen, let us take an helium. If you take an helium, if you remove an electron, what will happen from a helium atom? It becomes lack of 1 electron. It becomes a positive ion. And that electron which is detached or knocked out from any atom or maybe molecule may be interacting with any neutral molecule in the atmosphere, and those molecules becomes negative ions. The group of ions are called the small ions. Small in terms of the size, but ions are ions not in terms of the number. Small ions are the ions where the dimension of those ions are relatively less compared to the higher ions of that kind. This range, you see that the dimension is very less than 0.01 micrometer is known as the small ions, less than 0.01 micrometer is known as the small ions, and greater than that is known as the large ions. This is a very small number, and it lies with somewhere here. Starting from 1 nanometer to the order of about here, somewhere about 15, I can say that 15 micrometer, up to 15 micrometer, a chemistry plays a very important role, or including the pollutants. The particles which belongs to the size range from few micrometer, few hundreds of micrometer, few tens of micrometer, to few tens of nanometer, play an important role in pollution studies, in contributing the pollution, and also in the air chemistry. You don't go with the liquid chemistry and solid chemistry of that kind. It is the chemistry of the atmosphere, actually, they can call. And the size between about 0.1 micrometer, roughly 0.1 micrometer to about 15 micrometer, is having a great importance in atmospheric radiation and also optics, because we are having huge amount of the clouds, we are having a huge amount of the atmosphere. The radiation which is coming from the sun, of course, maybe from other stars to a minimal extent, but from the sun we are getting a huge amount of the radiation, particularly in the visible. Almost 50% of the radiation coming from the almost the radiation coming from the sun, 50% belongs to the visible, about 10 to 11% in ultraviolet, ultraviolet, about 39% in an infrared. 39% in infrared, almost 40% they can call infrared, actually. Okay, 3 classifications you can make. About 50% in the visible radiation, and that 50% visible radiation will interact with the atmospheric constituents. Here you are able to see the beautiful diagrams, different colors of the clouds, like gray color, white color, silver color, sometimes reddish in color, sometimes maybe green, like aurora australis and aurora borealis of that kind. Or even the sky also looks like a different color, actually, with different patterns, mainly because of the existence, mainly because of the existence of the dust particles in the atmosphere. If there are no dust particles, assume, if it is made of only pure gaseous molecules, the interaction may be different. You may not be able to see the sky with the clouds. It should be like open atmosphere. Atmosphere is open in the sense you may not able to see the air through naked eye. That's all. Because the dimension of the molecules are of the order of more than of the order of molecular level, angstrom level, actually, we may not able to see through the naked eye. Then this classification of large ions, it is huge ions they can call. These large ions, almost about from few micrometer to few nanometer to the extent of a few micrometer, will lie with atmospheric electricities. In the sense, maybe the dissipation of the ions, interaction of the ions with its neighboring molecule, and thereby controlling the charges in the atmosphere, or to attain the charge neutrality, they can call charge neutrality, because like all objects should be stable if they are on the earth. If you are taking them upper, potentially they are unstable and they will try to get attracted towards the earth. For example, even in atomic physics, if you take an electron from innermost orbit to an outermost orbit, you are saying that atom is said to be excited because of the absorption of the energy, and it will try to come back to the normal state or the stable state by attaining its least energy or the lowest energy. I'm explaining this in terms of the energy, particularly for the atoms. Similarly, for the any matter, of course, any kind, preferably of the solid or liquid, if you take them to a higher altitude or maybe higher potential gravity, certainly they may not remain there. They have to come back. They have to come back to the ground state. They have to come back to the ground state physically by the emission, by the movement, by attaining the least energy. Atmospheric electricity, what happens if you are having a independent charges, for example, after 100 kilometers from the surface of the earth, not horizontal, it should be a vertical, you will find an distinguishable charges. You will find a distinguishable charges in the sense isolated ions will be there. You will be finding only few electrons, not few actually, huge number of the electrons at some region, huge number of ions at some regions. They act like that region acts like an ionosphere, region of ions. Because of the availability of such a region of the ions, communication is possible. If you send a signal, preferably in the radio frequency, RF waves, those waves will get back to us in the shape of an parabola. For example, if you send it from India, it may be having it may travel to the ionosphere with a distance of about 300 to 400 kilometers, and it will come back by following the wave. Communication is mainly possible because of the existence of the ionosphere right now. Okay, earlier, but now we are using the satellite communications to a great extent apart from ionosphere. Here, after this, is still if you go up actually, you will get an one broad line, cloud and precipitation physics. Oh, I don't know, maybe physics means like what they can call thermal physics, mechanical physics, or hydrophysics, or maybe in solid state physics, nuclear physics, astrophysics, then condensed matter physics, CMP they can call. Here there is one kind of physics known as the precipitation physics, cloud physics, microphysics of clouds they can call. Micro means clouds are one of the greatest clouds, in the sense clouds are the one of the greatest ensembles available for the human being, for the earth actually, to study or to reveal the interior of the science, or particularly physics behind it actually. Formation and dissipation of energy, either kinetic energy, or the formation and dissipation of thermal energy, mainly because of the migration of water molecule from ocean to an land, and there may be some reservoir sources to the some other kind of a sink, depends on the formation of the clouds. Formation and dissipation of clouds is a very toughest task. The thing is that you can't go to the clouds, and make the observations, make the experiments actually how they are there actually. Now, one beautiful thing I can tell, that you might have seen several clouds in the sky, no doubt. They are floating mainly because of the buoyancy force. That's true, because buoyancy makes them to move upward, and the gravity makes them to pull downward. They will have some height actually, where there should be exact balance between the two. Okay, it's a simple physics, what you expect actually. But thing is that they're not static. It is not like one air balloon we are putting actually. The mass of cloud is also huge, high, several tons. Then they have the dimension. This base of the height will start about 1.5 kilometer, even to the extent of the 2 kilometer, to the maximum of extent of about 15 to 17 kilometer. Means tropopause is the maximum height. Nothing can move beyond the tropopause, preferably, but there are some clouds in the stratosphere, there are some clouds in the mesosphere. We'll call them as the noctilucent clouds, but their origin is somewhat different, not because of the water vapor and the molecules which exist by the suspended aerosol particles in the air. Now the aerosols will come into the picture. Okay, those clouds, formation and dissipation is tough task. And some clouds you may be seeing that different shape, very thick. They may not allow the light at all to penetrate through or to pass through. Means that is why you are seeing different colors of the clouds, mainly because of the interaction of or dancing of clouds with incoming solar radiation. If they allow the light, it appears white. If they don't allow the light, of course, in the visible spectra, it becomes dark in the sense like a blackish color, black color of that kind, because that absorbs all the colors. If it interacts with in a different way, the size of the particles ranges again from 10 to the power of -3 micrometer to positive 10 to the power of 3 micrometer. Then different scattering can happen, either Rayleigh scattering, Mie scattering, Tyndall scattering. The occurrence of the color, particularly the white or brightness they can call, the clouds appears white mainly because of a scattering. That scattering is known as Tyndall, Tyndall, Tyndall scattering. Okay, still if you go, we'll see that later. Okay, if you are very much interested, you can take up some project work actually later after completion of the first semester with any of the faculty members, doesn't matter. Okay, but if you are interested in some projects with atmospheric physics, I can help you actually. Broadly here we can classify these particles. Why classification? We are saying that periodic table is divided into several groups like gases and solids, liquids of that kind. Even according to size also one can classify. From here in the sense 10 to the power of -3 micrometer to that of almost about 0.1 micrometer, they can call 0.1 micrometer. They can call this nuclei as the Atkin nuclei. Atkin is a scientist. Developed an instrument to measure the concentration of the suspended particles in the air, and they have named the instrument, the Atkin instrument, and the nuclei also they call the Atkin nuclei, where the size belongs to 10 to the power minus 3 to or 10 to the power minus 1. Inside of that, all the size particles which are having a size less than 0.1 micrometer. You know, don't worry, maybe about 2 or 3, maybe there actually, it doesn't matter. Less than 0.1 micrometer are known as the Atkin nuclei. They are also classified as the small ions, small ions. Okay, small ions, please don't take it as only single ion. That several ions will sit on the molecules and becomes a group of small ions. Large particles between 0.1 micrometer till to the extent of about 1 micrometer. About 1 micrometer. It is not 10 to the power of 0 is 1 actually. 0.1 to about 1 micrometer. 0.1 to 1 micrometer is known as the large particles. Any particles of size greater than 1 micrometer are known as the gain particles, starting from 1 micrometer to extent of about few millimeters. It is a broad classification. How it will see that? How we will see that? One operator. Okay, here there will be different kind of sources of aerosols in the atmosphere. Sources, there should be source and there should be sink. Okay, what is the source for the water? Ocean is the great source for the water actually. Okay, clouds will form, water will evaporate from the atmosphere, from the oceanic environment and enter into the atmosphere, and it will precipitate as a condensation either on ocean or on land. Here we will see that I will go through the text, don't worry, and of course you can make use of the same text for your study material. Okay. Solid and liquid particles are released into the atmosphere either from plant and animals. While classifications are considered, before I forget, you can broadly classify according to the size. Here, according to the sources we are saying, like biological sources, solid earth also acts like a source. Anthropogenic sources means that is the man-made sources are due to the human activity, not human activity in general. Okay, in situ formation, wherever we are there, how that formation has to happen. This is the source. Things are different. We'll go each of the properties actually. These are the solid and liquid particles which are released into the atmosphere either from plants and animals. Plants releases like pollen grains, like dust. Animals like a cow dung, it gets evaporated later. Okay, and animals will not be cow dung. Even small insects. Okay, such type of thing. These emissions, which include seeds, pollen grains, spores, and fragments of animals actually. Okay, even fur and other type of things, and plants. Okay, which can have the size range starting from 1 to 250 micrometer in diameter. Particularly in Dhanabharati campus, it is a very good plantation. It is a very good forest with the huge number of trees. Okay, more than 4 lakh trees actually. More than 1 lakh trees with medical applications. More than 1 lakh trees are having medical applications. We are having such a huge plantation with biopark. They also emit the pollen grains. You might have observed those who are staying in hostel, particularly either boys or girls, particularly during rainy season, before rainy season, or during winter, you will get cold, cough, sneeze, so many things because of the viral movement, because of the virus and bacteria. Those will be more prominent in campus mainly because of the migration of the pollen grains, pollens, spores from the plantation to the human being. Since we are staying at the point of a source, okay, maybe we don't think that the trees will get the virus of that kind, but the migration is possible. That's why it is more prone for this type of an area. Particularly in the campus, we will find such type of migrations to a great extent, because if 1 or 2 persons gets affected, it will be transported very easily compared to a place with the dry lands, compared to a place with very cities, hardcore of the cities and such type of places. Okay. And like bacteria, algae, protozoa, fungi, viruses, all of them are having the size less than 1 micrometer in diameter. Can we see the size of the order of 1 micrometer? Think of some characteristic concentrations are maximum value of grassy pollens, which can have this range about 200 per meter cube in terms of number. Okay, around 200 pollens you can find in the grassy pollens. Okay, in a meter cube of area. But fungal spores in water, you'll find about 400. Bacteria over remote oceans, not interior, it should not be contaminated, about 0.5. You may not find, let it be only about one bacteria of that kind. But bacteria in city, if you expect about 80 to 800, almost 1,000, you just make it almost 1,000 times more than that. Of course, maybe even if you take 100 times, not an issue. On order of 2 to order of 3 will change. And bacteria over sewage treatment, you will get about 10 to the power of 4. That is why maintaining a sewage is of great risk, and it should be maintained very well. Otherwise, getting such type of diseases or infections will be quite high. Microorganisms live on skin, there is no doubt, either skin on human being or maybe on any of the animal. When you change your cloths, you can propel almost 10,000 bacteria per minute into the air with a diameter of almost 1 to 5 micrometer. The size of about 1 to 5 micrometer diameter. Okay, propellant is just what you can call shake it, the cloths. Okay, you will get about almost 10,000 bacteria. Now imagine, due to the corona or a kind of a virus, which is more prone to sit if it is on cloth, it will sit for quite a long time. And that's why government and other agencies, they are saying that strictly adhere to the regulations. Don't go outside. If you are coming outside, maintain social distance and maintain the cleanliness, hygiene. And if you go back to the home, don't carry the virus. Even if for some reason, if it carries one few viruses, it can be wiped out, it can be washed out, it can be erected before it is spreading from one human being to another human being. It is fortune, still it has not gone to the level of the animals and even pets. Over oceans here, the right side you can see the diagram here. What I want to say is that the same thing I will explain here. This is a top surface of the ocean. Of course, any surface of water body they can call. One air bubble will form. Air bubble is nothing but it doesn't have water. It is only an atmospheric air. Bubble will form in such a way that it occupies the volume of the water. Okay, water is pushed. Some of the air is on the top, some of the air. It is like a bubble. Okay, it is floating. Film droplets will form with the absorption of the energy. Once film droplets are formed, it breaks up where the water molecules will shake into shape. The water molecules will enter into the air. Once it enters into the water molecules, enters into there, it leaves by the absorption of the thermal energy from the oceanic layer, particular top layer, and it makes like a jet drops, like a jet. Once jet forms, the drops will leave the surface. Otherwise, it is difficult to take a water molecule from the water. Okay, it is not so easy. They are having a cohesive force. They are having an intermolecular weak force, weak binding force actually, which attracts every molecule. It is not easy to extract one molecule out of the water. It is not taking one drop of water. Taking one drop of water is easy. Extracting one molecule of water is very difficult task. Like only H2O if you want to extract it actually. Then jet will form. What happens? You see in the text. Over the oceans, some droplets and drops evaporate, which to leave the sea salt particles. Once it evaporates, along with the sea salts, it will go. Once it gets converted into the vapor, water vapor, it leaves behind the sea salts. That sea salt, which is leaving behind in the air, are the dust particles in the atmosphere, one of the dust particles in the atmosphere, and other kind of a material in the air. Okay. The time between the region from A to D here, this process is roughly 2 milliseconds. It will not take much time. It is not of the order of a few seconds to the few hours. The film droplets are almost here, what it was formed, 5 to 30 micrometer in diameter before it gets evaporated. The size of this jet here, what you are expecting, size jet of the drops are about 15% of the diameter of the air bubble. Diameter of the air bubble, what you are expecting here, this bubble, it is only about 15%. Assume that is about 1 millimeter, it is about 0.15 millimeter of that kind, not exactly 15%. Okay, about 0.15% you can expect. Many small droplets are produced, fine, no doubt, when the upper portion of an air bubble film bursts and are called the film droplets. Bubbles of dimension greater than 2 millimeter in diameter each eject almost about 100 to 200, the same thing, 100 to 200 droplets leave behind the sea salt particles with the diameter of the order of about 0.3 micrometer. From 1 to 5 large, almost here, 1 to 5 large drops break away from each jet that forms when a bubble bursts, and these jet drops are thrown about 15 centimeter up into the air. Almost 50, half a feet, it will be thrown. Once it is thrown half a feet, about 15 centimeter, wind above the oceanic water will take away the droplets along with the wind. That is the carrying agent. Once the wind is carrying these droplets, it will be migrated upward because of the buoyancy force and also because of the expansion. If they receive the thermal energy, density drops, it will move to the extent of 15-kilometer vertical altitude. This is one source. Another thing is that the solid earth actually, the transfer of the particles into the atmosphere from the earth's surface is caused by wind, no doubt, and also an atmospheric turbulence. Why wind? Wind has to move from high pressure zone to the low pressure zone. Okay, between cities and the rural areas, in the sense between Ramnagara and Bangalore, between what they can call Malur, then maybe in Tumkur maybe a little bit far away, maybe in Nelamangala, or maybe in outside like Hebbal. Hebbal is still interior. Okay, compared to that, city is always warmer because the more activities will go up, both by humankind and also because of the nature of the terrain with the concreted jungle they can call. The temperature of the city is relatively more, about 1 or 2 degrees more than that of its surrounding. It acts like a low pressure area. It brings much cold air from its surrounding to the land during daytime. Of course, it takes away the pollutants during night time from the polluted area of Bangalore city to its rural areas. Rural in the sense mainly because of the pressure gradient actually. Here what I want to say, the turbulence will happen mainly because as you move vertically, the temperature drops. Drop in temperature reduces the density and also to the pressure. And the atmosphere is well mixed mainly because of the availability of the thermal energy. Wind takes away the effluents, they can call, may not be pollutant, any matter, even including atmospheric air, okay, from one point to the other point. And due to the turbulence, it gets mixed up well into the atmosphere. To initiate the motion of particles on the Earth's surface winds speeds must exceed certain threshold value, of course, there is no doubt, which depend on the size of the particles and the type of the surface. If it is a smooth surface like ocean, it can take away to a great extent. If it is a surface like a land with the what we can call friction, uneven surface, it will be stopped. That is why the cyclones which are formed, cyclones are nothing but huge wind systems actually, which are formed well deeper inside the ocean, not depth-wise, well interior of the ocean they can call, few hundreds kilometers to 1,000 kilometers, will travel 1,000 kilometers over ocean. Once they approach the what we can call coastal line, particularly the region, a common region between land and ocean, as soon as it enters into the land, friction enhances and it will not travel to a great extent. That is why even Haki, the cyclone which was formed and making a devastation over Kerala and Goa and few parts of Karnataka like Mangalore actually, and it is not coming well inside. If it is coming, it could have been danger for all the people who are living on land actually, but certainly it fades away. And why? Because the transfer of the momentum through the cyclone, this huge cyclone on any hard obstacle is quite large actually, large. That is why even the tallest trees will be uprooted, some tallest buildings will be collapsed, erected electric poles will be uplifted actually. Okay, even some of the structures gets destructed mainly because of the transfer of the huge momentum. Okay. The size of the particles and type of the surface. The threshold value is at least about some 0.2 meters per second. If it's lower than that, we can't expect. And for a particles of about 500 to 200 micrometer, these values don't worry. What is the intention you think of actually? About few millimeter per second speed is required to take away the particles of the micrometer level. And for soils which may be containing 50% of the clay and the tilled soils also they can call. To achieve this frictional speed, it requires wind speed of several meters per second, a few meters above the ground. A major source of smaller, particularly between up to 100 micrometer particle is the saltation, in which large sand grains becomes airborne. Large sand, what the sand you are expecting, that becomes airborne, particularly the Sahara Desert, the Thar Desert, even Rajasthan Desert. Okay, it puts the huge amount of dust, particularly the dust from the desert, particularly dust from the desert through the sand desert they can count. Fly a few meters and then land on the ground, creating a burst of dust particles. On global region, almost deserts, it covers about 1/3 of the land surface, are the main source of the particles from the Earth's surface, and it provides almost 2,000 tons, 2,000 teragrams per year. Don't get confusion. TG is nothing but 2,000 tera. Tera is 10 to the power of 12 grams, or maybe about gigatons, you can call gigatons in terms of kilogram, gigatons of mass for every year as a mineral particles. Now, don't call it as a mineral water, what you are expecting from minerals, that also the mineral kind actually. Dust from these sources can be transported over long distance. Volcanic eruptions particularly, inject the gases and particles into the atmosphere. The large particles have short residence time, there is no doubt. Small particles should have the long residence time. In the sense, small particles will remain in the atmosphere for longer duration, and the heavier one will not. Either that will be settled through the gravity, or will be washed out through the precipitation, or will be converted into the some other particle. It is mainly produced by gas to particle conversion. I don't know, you get it or not. Gas will convert it into the particle. Now remember, gas gets converted to the solid. Particle can be converted into the gas. Either the way, both processes are happening in the atmosphere. Gas to particle conversion, G2P conversion of sulfur dioxide. Sulfur dioxide is one of the pollutant. Of course, gas need not be pollutant. Okay, can be transported globally. Sulfur dioxide can be transported globally from one point, from source to the sink. Which are the sink? Preferably, ocean is the sink to a great extent. Now, poles are the sinks, and atmosphere is the sink. Okay, particularly if they reach high altitudes. Particularly in the sense, they have to move relatively about tropopause, and can freely move across the globe. Volcanic emissions play an important role in stratospheric chemistry. That will change. For example, if one volcano happens anywhere across the globe, like Pinatubo, one of the volcano in 1992, so many names they will call actually, that introduces the huge amount of the dust particles, gases into the air. Once because of that high pressure, if they cross the tropopause, that will be entered into the stratosphere. But from stratosphere to the tropopause will not allow the particles to come back. Those particles will migrate and encircle entire globe. Due to the volcanic eruption, it also leaves the high temperature, energy, heat content. But thing is that locally it will be warmed, but it introduces several thousands of tons of gases into the atmosphere. It encircles and makes like an umbrella for the earth. Umbrella means it is completely blanketing the earth at the stratospheric height. Okay, after eruption, after volcanic eruption, if it encircles such an height throughout the globe, the incoming radiation from sun will be attenuated, will be blocked, and thereby reducing the global temperature by about 0.5 to about 1 degree, either Celsius or Kelvin. I don't know. Average global temperature of the earth reduces by about 0.5 to about 1 degree Celsius due to the eruption of large kind of volcanoes that you can feel it. Means to say that, assume that volcano occurs about 10,000 kilometers away from you. Even there's a huge volcanic eruption. It may take about 2 to 3 days to encircle entire earth. Then the drop in temperature but by 0.5 to 1 degree Celsius will be noticed by such an impact. If there is no atmosphere, the energy will not be taken from source to the sink. Means always equator gets warmer and warmer, polar regions gets cooler and cooler. If there may be an imbalance between these two, it will not happen. Or land will gets warmer compared to that of the oceans is a tough task. You can't keep one end at hot zone and another end at the cold zone. There should be a balance. Means atmosphere plays a very important role. Aerosols are playing a very important role in the dissipation of the heat, in the dissipation of the energy from source to the sink. Third category, anthropogenic We'll move a little bit fast. Okay. The anthropogenic is nothing but man-made, human-made. Okay. Due to all sorts of activities, like an vehicular activity, or maybe use of the refrigerators, use of the fuel, like whatever you can call, for burning of the fuels. Okay, even burning of something like that, even fire camps, so many things. Whatever the man who is making it for its comfortness, that becomes the human activity. From the human activity, we are getting huge amount of aerosols into the air. The global input of particles into the atmosphere from human activity is almost about 20% by mass. Of that from natural sources. Natural sources are also there, like forest fires, okay, and volcanic eruptions, cyclones, hurricanes, so many, even deserts, dust devils they can call. The main anthropogenic source of aerosols are dust from roads, okay, wind erosion of till land, biomass burning of the biomass for fuel combustion for vehicular activity, starting from two-wheeler to any number of wheels, industrial exhaust and industrialization. Then for particles with diameter which is of the size greater than 5 micrometer, direct emissions from anthropogenic sources which dominate over aerosols that form in the form of an atmosphere by gas to particle conversion. That conversion we are referring it as the secondary particles. They are not from primary, okay, of the anthropogenic gases. However, the reverse is the case for the most of the smaller particles, for which gas to particle conversion is overwhelming or is exceeding the source, particularly the number of the concentration of anthropogenically derived aerosols. In 1997, here they are making mainly because that is the reference time actually. Worldwide direct emission into the atmosphere of particles of size less than 10 micrometer diameter from anthropogenic sources was estimated about 350 teragrams. Tera means about the 350 gigatons per year, excluding the G2P conversions. Almost about 35% of the number of concentration of aerosols in the atmosphere was sulfate produced by the oxidation of sulfur dioxide. If oxidation of sulfur dioxide, sulfur mixed with oxygen, sulfur dioxide mixed with again oxygen, sulfur trioxide mixed with the water, it will get H2SO4. H2SO4 is an acidic in nature and produces the ions by the breaking of an H2SO4 to an sulfate, SO4 minus or SO2 minus of that kind. Particle emissions worldwide here were dominated by fossil fuels, okay, and biomass burning. These emissions are projected maybe to a double by the year by 2040 due to largely by anticipating the increase of the use of the fossil fuels from and the combustion of the fossil fuel, with the greatest growth in the emission from particularly the two countries which can contribute everything, China and India. Preferably, the population of India is about 36 crore. Almost the China is also 140 crores. Between the two, we are contributing almost 270 crores of population, worldwide population, more than more than 1/3. During 20th century, the emission of particles into the atmosphere from anthropogenic sources was very small, okay, but by 2040 it gets doubled. It is the speculation and also models tells us that if the continuity of the same thing. Fourth category may not be of the order, in situ of formation. At this spot, how they will form actually. You can read also in detail, there is no doubt. In situ condensation of the gases, for example, gas to particle conversions is important in the atmosphere. Gases may condense onto the existing particles, that is the condensation process, what they are calling, thereby increasing the mass, but not the number of the particles. Okay, mass will increase. As the mass increases, density increases. As the density increases, it has to settle due to the gravity. Or gases may condense to form new particle from one kind of a particle to another kind. The former path is favored when the surface area of existing particle is high, means it is relatively more, and the supersaturation of the gases is also low. If new particle is formed, they are generally of the diameter of about size less than 0.01 micrometer. They generally call it as the small particles. Small particles are the sizes which belongs to the small. Okay, the quantities of aerosols produced due to the gas to particle conversion exceeds those from the direct emissions for anthropogenically derived aerosols and are comparable to the direct emissions in the case of naturally derived aerosols. Three major families you can expect, that is the sulfur, compounds of nitrogen, and compounds of organic and carbonaceous materials. Various sulfur gases, for example, H2S, you are getting the foul smelling of the rotten egg or rotten dead bodies of any living organisms, where the smell whatever you are getting is mainly because of the emission of H2S. Even in lab also one can generate H2S, that may not be the rotten one of that kind. CS2, then COS, DMS, dimethyl sulfide of that kind can be oxidized to the sulfur dioxide. Once the sulfur dioxide is entered into the atmosphere, it can oxidize it to the sulfate or will be dominated by SO4 sulfur SO4 2 minus phase, where it is having a more lifetime, okay, and routes being reactions. However, on global scale, like heterogeneous chemical reactions can happen from SO2 in cloud water, which can dominate by the conversion of SO2 to the SO4 2 minus, not direct way. SO2 gets converted to SO3, SO3 to in presence of water H2SO4, H2SO4 to SO4 2 minus. Over the oceans, these sulfates derived from dimethyl sulfide, they can call DMS, contribute to the growth of the existing particles. Sulfates are produced in and around clouds, and nitric can form from N2O5 nitrous. This they will call it as a Sescu oxide N2O5 in the cloud water. That is why cloud particles are not treated as the what we can call aerosols. Subsequent operation of cloud water releases these sulfate and nitrate particles. Organic and carbonaceous aerosols are produced due to the gas to particle conversion from gases, which are released by the biosphere, and from also volatile compounds. Like any volatile compounds you can take, like benzene or methyl alcohol, ethanol of that kind. So even including the petroleum products, such as the crude oil that leak to the Earth's surface from well deeper inside oceans. Carbonaceous particles emitted directly into the atmosphere from biomass. Okay, you can just note down some of the sources. Sinks are the oceans to a great extent. This gives us only a rough estimate for the pollutant, not pollutant, aerosol particles, particularly teragram per year from direct particle emission and also an in situ production. Number they have mentioned that in the northern hemisphere what should be the number, in the southern hemisphere what should be the number, because land is more on northern hemisphere compared to the southern. Okay, organic matter about 28, this is about 26. Just least you just go through. It's only for comparison and to have a number for you and to have a quantification for your understanding. And this is also a possibility of the chemical composition of the aerosols they can call, like carbonaceous, industrial dust, sea salt, mineral dust, here preferably sulfates, nitrates, organic compounds. Okay. As the number and the sizes are considered here, this is one of the oldest and most convenient technique for measuring the concentration of the particle in the air is by making use of some counter, like GM counter you might have heard, particle counter you might have heard. GM counter, what it does, it estimates, it gives you the number of the alpha particles which are entering into the chamber, or beta particles, or maybe gamma particle. Okay, gamma can't be measured, either alpha or beta, and even to some extent gamma also, because you are using the cobalt source, cesium source, or barium source, or some kind of it. What it does here, there actually there should be an ion chamber. Ion chamber will be exposed to the ions, where entering ions will ionize the gases. Because of the ionization, the ions will migrate towards the respective electrode, thereby giving you the current. Each ions will represent one ionization. Each ionization represent the entry of one energetic particle, either alpha or beta, maybe followed by gamma of that kind in GM quantum. Okay, where you studied well. This is also the same instrument, similar instrument of that kind. Okay, where saturated air is expanded rapidly, saturated in terms of the water vapor. Okay, saturated air is expanded rapidly so that it becomes super saturated by several 100% with respect to the water, no doubt. At this high super saturation, water condenses naturally, virtually on the particles. Once the water condenses on the particles in the form of air, in the air, to form small cloud droplets. The concentration of these droplets in the cloud which is close to the concentration of atmospheric particles, can be determined by allowing the droplets to settle out onto a substrate where they can be counted under microscope. It is a physical instrument. It is not an electrical instrument actually, or electronic equipment, okay, or automatically by a optical technique. Earlier, the person was developed during 1900 actually, almost more than 100 years. Okay, there was no technology to make the instrument into the different way. They used to make the count of the particles physically, okay, using a microscope or maybe onto an optical technique. If you allow an optical radiation, any radiation, okay, how that can be measured? Even laser was not there. The concentration of particles measured with this equipment are known as Atkin nuclei or condensation nuclei. This condensation nuclei, they will call it as CN, Atkin counter or condensation counter. Condensation of these nuclei counts near the Earth's surface vary widely from one location to the another. Preferably, deserts must have the larger values, forest must be having a larger values, ocean may be having relatively larger values. At the same time, polluted areas are also having larger values of land mass, can fluctuate by more than an order of magnitude with time at any one site. For example, here the range from average concentration almost 1000 particles per centimeter cube over oceans. 1000 particles you can find aerosols. These are not the pollutants, remember, okay? And about 10 to the power of 4 over rural areas, about one order of magnitude more. And about 10 to the power of 5 in the cities, urban polluted cities, almost 2 orders. These observations, together with the fact that the condensation nuclei counter counts decline with increasing the altitude, number decreases as you move vertically upward, support the view that land is an important source of atmospheric aerosols. Land is the only agent, means any land is the source of aerosols, with human and industrial activities being particularly prolific sources are the major sources of that kind. How it has to go? Remember this one graph actually, these are the two slides only, okay? What happens here? Atmospheric aerosol particles range from 10 to the power of -4 micrometer, almost about 1 angstrom, to the tens of micrometers, no doubt. The averages of the numerous measurements of particle number distributions in continent, on land, ocean, and urban polluted area. Okay, there are no single equipment that can give us the measurement of the size of the aerosols starting from 10 to the power of -4 micrometer to about 10 to the power of 3 micrometer. Remember, that is the drawback. We can't have the measurement, means we can't have the technique to measure all. For example, if I go for the lower dimensions up to about 10 to the power of -4 to about 1 micrometer, maybe one kind of an equipment, about 1 to 10 micrometer, another kind of an equipment, about 10 and above, maybe another kind of an equipment, because the techniques are not so easy to make the measurement. Because I will tell you, you may be buying vegetables from the shops, okay, vegetable vendor, okay, you may having certain kind of a weighing machine, maybe starting from about, he may not require about 1 gram sensitivity, maybe about 10 gram, more than enough, okay, only 10 gram, okay, 10 gram is enough, because nothing can come less than 10 gram, maybe unless you buy some what they can call beans or maybe chilies, except them of that kind, you may get all of them. If you want to make the measurement of a potato, even 10 gram, 20 gram may not be insufficient, it may go with any value. If you go to a grocery shop, it may go with the few grams. For example, if you take some spicy items like whatever, dalchi, gilchi or something like that, or if you go to a jewelry shop like gold, oh, you can't have the same weighing machine of the order of grams. Every milligram makes you a cost of several thousands, okay, several thousands. That is why weighing machine varies from one application to another application, starting from the jewelry shop to the vegetables to the grocery to the even to the person who is selling the vegetables. If I want to take the mass of weight, for example, weight of a lorry, load of a lorry, certainly that weighing machine should be different. Maybe weight of an entire planet. Oh, mass, we can't call it as a weight of a planet. Oh, can we call it as a weight of a planet or mass of a planet? Think of mass and weight. You expect that there should be W is equal to M times G. If G is 10 almost, W and G will get almost 10 times the difference between 10 times the value, which should differ actually. Okay. So entire thing you are calling it as a weight of a substance on the land, okay, or maybe ocean. Can I say that the mass of the earth or maybe weight of the earth? Just think it of, or mass of a planet or weight of a planet. Think of. What we are discussing here. So, yeah, only single instrument is not available. There may be n number of instruments. Means a set of instruments differ actually. That covers no instrument covers entire size. Okay. The measurements are plotted, particularly these numbers. Particularly, we want how many particles are there in that size. Okay. Where direct value of the R value, if you plot number against the diameter is not a good idea. Preferably, they will plot the dn number of particles in the size range for a given size distribution, and the y-axis is in the form of the d are plotted on logarithmic scale. All of them are in logarithmic scale. dn by d log d, where the dn is the number of concentration of particles within a diameter of d to d plus d. Assume that here, where I can say here about 10 to the power of minus 4 to 10 to the power of minus 3, how many particles are there within this window? Okay, some number you will get about 100. Within 10 to the power of minus 3 to 10 to the power of minus 2, how many? Or maybe 10 to the power of minus 3 to 10 to the power of minus 1, how many? Cumulative number. That is why dn is the number of particles within that size. Okay, number of particles within size for a logarithmic of d value of that kind. Okay, since the number is changing quite a lot, we are taking dn by d log d. The concentration of particles fall off very rapidly as the size increases. Okay, therefore, the total number of concentration, particularly for either Atkin or maybe condensation nuclei, is dominated by particles with diameter which should be more than 0.2 micrometer, which are therefore referred to as the Atkin nuclei or condensation nuclei. These portions of the number of distribution curves that are straight line in figure can be represented by an expression log of dn by d log d is equal to constant minus beta log d. Just it is an expression. Dn by the same expression dn by d log d should have some constant minus beta times log d. If you take an anti-log, dn by d log d should be equal to c times d to the power of minus beta only for d. It should be expressed in terms of the curve. This curve should be referred actually. I will explain, then we'll come for the curve. Where c is a constant, there is no doubt. Related to the concentration of the particle, minus beta is the slope. Minus beta is the slope what you are getting here. Where this is the plot of the change of diameter, okay, versus dn by d log d. Means range of the particles dn for any diameter range. Within this range, this is the value. Within this range, this is the value. Within this range, this is the value of that kind. Okay, between is the slope. The value generally lies between this beta value lies between 2 and 4. And for continental aerosols, means that is for the land actually, the diameter is about 0.2 micrometer. Here also micrometer, remember, okay, which follow closely to the value of beta is equal to 3. A size distribution, how that size distribution can happen is particularly known as the Jenge distribution. This is the name of a scientist. Okay, he worked out. Don't worry with the in detail information. The size varies according to that. You are requested to know this plot, and you should plot when they ask in the exam. Okay, maybe curve may change. It doesn't matter actually. Change the diameter of 10 to the power of minus 3 to about 10 to the power of 2 micrometer to a great extent. Take about 10 to the power of minus 6 to about 10 to the power of plus 6 or 10 to the power of 7. This is the contribution. Okay, for every centimeter cube of the volume. Okay, one line from here to here, where dn by d log d is directly proportional to the d to the power of minus 3, inversely proportional to the diameter, we can call it. As the size increases, as the size increases, number of particles will come down. As the size increases, the numbers of particles will come down. Okay, smaller size particles are having great in number, the larger particles are having less in number. There is no doubt. Here, the size, you can say that up to this here almost about 0.1 micrometer, roughly a few 0.5 micrometer they can call. Up to about 0.5 micrometer is the small. Large between 0.5 to about 1 micrometer, then greater than about 1 micrometer is known as the gain particle of that kind. The number distribution of these particles confirms that the condensation nuclei measurements, which indicate that the total concentration of all the particles are on average greatest in urban polluted air and the least in the marine air. Here, these are the different colors actually they can call. where I have shown, yeah, some color should be there. Okay, the concentration of the particles of size less than 2 micrometer, sorry, greater than 2 micrometer, you can known as the two particle. One also you can put on average, rather similar in continent, marine, and urban polluted area. Further insights into the atmospheric particle size distribution can be obtained by plotting particle surface area and the particle volume, or even if in surface area distribution, if you take surface area wise, instead of diameter, you can plot the number with surface area of the particles which are available on the d-axis on logarithmic scale, where S is the total surface area of the particles and the diameter has to lie between d and d plus dd. In also you can plot in terms of the volume against dv by dd. All these three curves, either in terms of number or in terms of the surface area or in terms of the volume, it looks more or less same. Air pollution will also come into the picture here. In urban and industrialized locations, human-made activities or the emissions due to the human-made activities can become so large that the concentration of various chemical species like pollutants cause significant deterioration of air, or quality of air will come down, and visibility can be reduced and pose threats to the human health for several reasons. Several air pollution episodes which exist right now are associated with the visibility reduction, no doubt, because flights will get cancelled, the visibility reduces mainly because of the pollution, particularly the places like Delhi, Hong Kong, Hawaii, okay, occur when the rates of emissions or formation of pollutants greatly exceed the rate at which the pollutants are dispersed by the wind. Because once the pollutants are formed and enter into the atmosphere, they will be dissipated. They will not stay there. But thing is that the reaction should be in such a way, if it will be lost, production and loss are at the same rate, there is no doubt. If the production increases or the loss mechanism reduces, then the entry of the pollutant will be quite high. That will change the phenomena, that will change the weather phenomena in a phenomenal way. Okay, where the pollutants will not be dispersed by the winds and also in vertical transport, or may be removed from the atmosphere by chemical reactions or by deposition. Several air pollutant episodes tend to occur in association with the extended intervals of light winds and strong static stability. The scale here it shows that in such a way. Some residence times, sinks are there, sources are there, how they can classify. Atkin nuclei, large nuclei, gain particles, this classification. Sources may be combustion or maybe wind blown dust actually, gas to particle conversion within this size, like fly ash, sea salts, pollen grains. And here within this size, coagulation means mixing of coagulating the two particles, combining these two particles, cloud droplets and even including evaporation. Here may be gain particle from industries, it will contribute. What are the things? Due to the coagulation, these particles will be lost or it can be captured by the clouds also here in this region. But the same case here this size, there is dot here, no, there is no mechanism here. Large particle will not be lost. There is no doubt actually here. Still it is an ambiguity. Here precipitation will go and scavenging will go. Scavenging in the sense washout they can call. Gain particles can be washed out. Dry fallout can be washed out. How long it will take? For these nuclei, residence time is about less than an hour to in polluted areas and clouds. About an hour, almost at most. Almost an hour, not half an hour. 1 hour it can remain. That's all. After 1 hour, it will sink. Here, large particles, days to weeks it will stay. Here, this range about hours to days. Here, this range in the sense which size. Here, minutes to hours of this kind, minutes to hours, and if particularly this size gain particles are there, it may remain in the atmosphere for days together. This is one more diagram. The same thing here. Sorry. Here, you missed this color, no? Where I mentioned. Here different colors are there. Different colors for one for continental, one for land, ocean, and another for urban polluted region of that kind. Urban region of that kind. Here, further insights can be classified based on plotting the surface area and rest of the part of that kind. Here the same thing. Here we are saying that the black color is for the urban polluted area. Red color is for the continental line. This one here, and marine air will be blue. Size simply this size with number. We are having huge number peaks at 10 to the power of minus 1 micrometer. 0.1 micrometer is the peak value for polluted particles, particles with pollution like sulfur dioxide, sulfur trioxide, carbon monoxide, carbon dioxide, compounds of sulfur, compounds of hydrogen, compounds of nitrogen, compounds of sulfuric acid, compounds of sulfate, so on and so forth. Okay, this way. Here about few 10, 5, about 5.5 micrometer is for the continental. For the about 1 micrometer is the far. See that here the huge number, the value changes almost by 2 order of magnitude for the polluted level. These two, continent and land, you can expect. Preferably continent should be more compared to that of the oceanic environment. Hardly it is not a much value actually. Both are having a peak at only one peak of that kind. I told actually it's on the last glimpse I can say that aerosols play a very important role in the atmosphere. Aerosols can obstruct the incoming radiation, thereby changing the temperature, changing the weather phenomena, and long trend may lead to the change in the atmospheric waves like Rossby waves, Kelvin waves of that kind, and it changes the temperature, it changes the pressure, it changes the visibility, it also changes the rest of the point. Aerosols are the particles which can transport the energy from source to the sink. Okay, fine. Without aerosols, atmosphere could have been gone beyond some extent, and the atmosphere is warmer mainly because of the availability of the aerosols only. If there are no aerosols or no dust particles in the air, the planet should be a cold planet, because they are the one which can transport the energy, they are the one which can absorb and re-radiate energy back to the environment. Because of the re-radiation, we are getting the warmer. But thing is that if we are introducing more and more aerosols, that may lead to the devastation. That is why people are saying that we have to reduce the amount of the carbon dioxide, particularly because the compounds of the carbon may happen either in terms of the carbon dioxide or carbon monoxide of that kind, preferably carbon dioxide. Their lifetime is of the order of 100 years. Even single dust particle of carbon will remain in the air for 100 years. Okay, if you are introducing more and more carbon dioxide, certainly the temperature of the atmosphere will go up. From last 50 to 60 years, 6 decades, temperature has gone from 1 degree, more than 1 degree, because of the entry of the carbon dioxide. Earlier it was about 280 particles per million before 1960. Now about 410, almost about 150 ppm has increased, more than 1/3. Okay. What happens is that lightning can also happen. The clouds will form mainly because clouds are formed mainly because of the availability of the dust particles. If there are no dust, the clouds will not form. Air molecules have to sit on a dust. Air molecules have to sit, not air, water molecules. Water molecules have to sit on a dust. Once water molecules sit on a dust will be migrated or transported from one point to another point. Clouds are also formed, a huge amount of the droplets they can call, and they also have the charges. The charge, if you expect, actually it may be about 40 to 50 coulomb of the charges. 1 coulomb is equal to, you estimate how much the charge it can dissipate. Okay, as you move up, actually 0 degree will get around about 5 to 6 kilometer, minus 10 around about 8 kilometer, minus 20 around about 10 kilometer, that kind. This is about 12 kilometer. Maximum extent of the tropopause anvil is at a height of tropopause. The top charges are positive and the bottom. The main charging zone is about almost at a region where the temperature lies between minus 10 to minus 20 of that kind. Here this is a kind of a precipitation to the ground. All bright clouds, silver clouds, very good, but at the same time they are so dangerous because updrafts and downdrafts should be quite high. Like cumulus clouds, cumulonimbus clouds, altus clouds, altonimbus clouds, stratus clouds, stratonimbus clouds, and cumulus clouds of that kind. These are the classification of the clouds, but we'll go detail if we take up any such type of subject actually. But thing is that they are the vertical dimension of about 10-15 kilometer, but with the horizontal dimension of several hundred kilometers. These are the pictures of the lightning activity. Lightning, thunder, gudugu, minchu, ನೀವು ಇನ್ನೊಂದೇನು ಹೇಳ್ತೀರಾ, ಸಿಡಿಲು. ಇದಕ್ಕೆ ವ್ಯತ್ಯಾಸ ಏನಂತ ತಿಳ್ಕೊಬೇಕು ಕನ್ನಡದಲ್ಲಿ. ಗುಡುಗು, minchu, sidilo. Lightning, thunder can happen at any time. If the atmosphere is unstable, certainly lightning can happen. And always lightning struck, not always, lightning always need not struck only the tallest objects, because lightning is nothing but the discharge of an electricity from sky, atmosphere to the ground. Three kind of lightnings can happen: lightning between the clouds, lightning between cloud to the ionosphere, lightning cloud to the ground, within the clouds, intra cloud, between the clouds, cloud to the ground, cloud to the ionosphere. Okay, if it is between the clouds, charges will exchange, because negative ions, preferable ions, negative ions gets attracted by positive ions gets attracted by negative ions, and thereby making them the neutrality. Once they are combining, if you sprinkle a water droplet on a boiling oil, you will get a huge sound, breaking of water molecules with huge intensity of sound. Intensity means that is in terms of the intensity of the sound. The similar phenomena will happen in the air when there is an exchange of energy between these ions. Energy will be released. That released energy is enormous. That released energy ionizes the atmospheric gases. Once it gets ionized, the electron will be knocked out. Once electrons get be knocked out, it emits a photon. That photon is nothing but the lightning activity with the lower. Lightning may be in any branches, like primary lightning, secondary lightning, so many kinds they can call. Will not touch upon that at least. Okay, see that this is in general they can happen. This is the earth, always treated as the negative. Everything should be grounded. All electrical instruments you are grounding to minimize the electric shock. Okay, electrical shock. Even the devices should be grounded. Okay, because of this, positive charges will accumulate at the base of the cloud, negative at the middle, then again at the positive at the top. Actually, due to the lightning, charges will dissipate towards the earth. Once it gets dissipated, it makes entire one electric circuit, they can call. This circuit is known as global electric circuit, GEC. At any given amount of time, almost amount of time means for every minute or for every second of that kind, almost about 2000 lightnings will happen across the globe. Around 2000 lightning will happen across the globe. Assume if each lightning gives you a current of about 1 ampere of current, 1 ampere is also sure, but they may give more current actually. Assume that 1 ampere of current will be released to the atmosphere. 2000 lightnings will give you the 2000 ampere of current. Now, in our electronics lab, you handled several equipment. You are well versed with the several experiments in such a way that if you give more current to the any of the devices will go. Means like for example, ICs will go, transistors will go, resistance also will break, capacitance will break. Every capacitor is having a capacity to hold the charges. There is no doubt. Atmosphere is also holding some charges, no doubt. If you are continuously introducing so much of lightning activity, due to the lightning, so much of charges are introduced, and the current will be of the order of about 2000 amperes of current for any given minute. Resistivity of the air has to break. Here the concept will come. Resistivity of the air has to break. Once the resistance breaks, you will get shock. Means we are having a transmission lines, electric pole connected by wires, conductor. Yeah, electricity is transported without touching. They may be separated by 1 meter. If the Earth's atmosphere is treated as right now insulator we are treating, if it is in conducting media, certainly the transmission lines was a difficult task. But during lightning, we'll get the shock. We might have heard several cattle might have died, several persons might have died, several trees might have struck due to the lightning and caught fire. Several trees might become dry after they were hit by the lightning activity. But thing is that so many lightning activities are happening. How to stop them? We can't stop. There is no doubt. We can't minimize them. There is no doubt actually. But this is the mechanism where it is making a balance between the charging and discharging process. Like the accumulation of the charges by all means, including ionization due to radioactivity near the surface, ionization due to the ionization of the atmosphere due to the entry of the cosmic rays, ionization of the atmosphere due to the entry of the ultraviolet radiation from the top of the atmosphere. Okay, everything will lead to the ionization. This ionization, we are having the ions in the atmosphere. Those ions have to dissipate. It gets neutralized. That neutralized phenomena is known as fair weather current. Is nothing but, even if you take a wire, on average vertically you will get about 100 volts for every 1 meter altitude. 100 volts for every 1 meter altitude. If you are having a height of about 5 feet, almost 1.5 meter, take two wires. One wire you can keep at the foot, another wire you can keep at your head. Connect those two wires to a battery. Sorry, maybe a battery in the sense voltmeter, or maybe you can connect it to a bulb. Okay, bulb has to go with a potential difference of 150 watts for every height of a person on India, over India. But it will not happen mainly because the resistance of the earth is very less, resistance of the atmosphere is very high, resistance of the atmosphere is very high, but it will break during the lightning activity. The potential of the lightning is of the order of several thousand volts to several 10,000 watts during lightning activity. In normal case, it is about 100 volt per meter. Fair weather will form, going and coming back of that kind. It is rising, moving and discharging, moving, rising and discharging. It acts like an electrosphere. I will end here. If any questions are there, I will take it up. Otherwise, we will move on to the next class. I will stop sharing the screen. Maybe I invite the questions if there are any particular questions of that kind. Thank you. Sorry for taking the class on Sunday and occupying you, but there is no other choice for me also. Chairpersons will discuss. The classes will go up to the 9. I may require another 3 or 4 at my not. Otherwise, I will wind up the class before that. Maybe numerical problems will keep it for last 1 or 2 classes. Some 2 classes are required. If you don't mind, I will engage regular class on, of course, there is no choice for you. 21st, I will engage. If nobody is there, I will engage 1 hour on 22nd Saturday, for Saturday. Maybe other classes according to the new timetable. Thank you. Thank you, one and all. I will stop recording first. I will invite the questions. Chandan, Pujashri, Kavya, Harish, Jansi Lakshmi, Kiran.
Sir.
Yeah.
Sir, ಮಿಂಚು ಮತ್ತೆ ಸಿಡ್ಲು ವ್ಯತ್ಯಾಸ ಏನು ಸರ್?
ನಾನೇ ಕೇಳಿದೆ, ನೀವು ಮತ್ತೆ ನನ್ನೇ ಕೇಳಿದೆ. Okay, lightning is the any kind of a thunder. Minchu andre discharge of electricity, whatever you are able to see the light part of it, optical part of it. ಆಯ್ತಾ? ಮಿಂಚು ಅಂತ ಕರೆದ್ರೆ. ಸಿಡಿಲು ಅಂತ ಅನ್ನೋದನ್ನ ಸೌಂಡ್ ಸಿಡಿಲು ಅಂತ ಕರೀತಾರೆ. ಸಿಡಿಲು ಮತ್ತೆ ಗುಡುಗು ಎರಡು ಒಂದೇನೆ. ಸಿಡಿಲು ಹೊಡಿತು ಅಂತ ಹೇಳ್ತಾರೆ. ಆಯ್ತಾ? ಸಿಡಿಲು ಗುಡುಗು ಎರಡು ಒಂದೇ. ಗುಡುಗು ಶಬ್ದ ಸೌಂಡ್ಗೆ, ಆಯ್ತಾ? ಮಿಂಚು ನೀವೇನ್ ನೋಡ್ತಿರಲ್ಲ ಅದನ್ನ, always we are hearing the sound few seconds later after seeing the lightning.
Yes, sir.
Because the light has to travel at a faster rate compared to the speed of the sound. But people are also sometimes they are seeing that as you look into the sky, ears are little bit few centimeters away from eyes. That's why it is getting delayed. Yarda kelo logic. People are also saying that the God is always laughing. And because of the laughing, God wants to take the photography of all the human beings. That's why lightnings are occurring. It is a beautiful subject. Okay, of course, all subjects are exciting only. There is no doubt. Whoever the teacher teaches you the topics, they will always say that that is one of the on priority. Of course, every topic is on priority. It is there actually. There is no doubt. Okay, only see. Scoring marks and getting first distinction, there is no doubt in your semester scheme with 30% of internals. There is no doubt you will score better marks. But to try to understand the phenomena from all respects, need not be atmospheric science. All the papers put together, you will be a physicist after 3 semesters. Almost one first semester is over. Thank you. Any queries are there? If no, maybe if time permits, I can take only one topic on lightning activity, not under from your syllabus. That is different. I am one of the expertise in the country who are working on lightning activity. Thank you. I'll end the meeting or the class.